Now let's look at our video appendix with useful data and research that supports our presentation. When sulfur oxides and nitrogen oxides are added to the culture fluid consisting of water and algae, the gases are dissolved into water-soluble compounds. The algae then use these compounds as nutrients during the process of photosynthesis. When carbon monoxide is added to the culture fluid, the algae oxidizes the carbon monoxide into CO2 during darker times, such as nighttime. This CO2 is then converted to oxygen in the photosynthesis during daytime when the culture fluid is exposed to light. So here we can see the numbers from the National Renewable Energy Laboratory study on how algae breaks down the pollution from flue gas. A 100% injection of the flue gas into a pond with algae gave a reduction from 9.6 kilo of PM10 to 2.2 kilo, and a 50% injection of the flue gas gave a result of 5.9 kilo PM10. The particulate pollution smaller than PM10 was reduced from 47 tons to 10 tons by the 100% injection and 28 tons with a 50% injection.
The second part of the appendix focuses on biofuel. Biofuel is another key product of our system. A research by the US Defense Department and the US Department of Transport shows that biofuel with 50% of blend of hydroprocessed alga oil and 50% of ultra-low sulfur diesel reduced PM2.5 by 25% compared to neat ultra-low sulfur diesel. With regards to the cost of this process, a startup Algenol managed to cultivate and process 8,000 gallons per acre of algae biofuel at $1.27 per gallon. When compared to the current price of ultra-low sulfur diesel in the US at $2.5 per gallon, this process of converting algae to biofuel results in not only saving for consumers, but also reduction in carbon footprint by 8 times, and also PM2.5 level. To sum it up, this idea not only helps to reduce PM2.5 and CO2, but also can be used to produce biofuel for different applications. It is also interesting to include in the appendix the calculations for the indoor application that refer to our bioreactor system. Considering that the filter now cleans 7 liters of air per minute and the average US private office is 17 square meters, 4 filters can clean one office in one day. This is because the average office has a volume of 42,500 liters, and the 4 filters can clean this volume in approximately 24 hours. Let's now analyze the technology.
First, the quit technology maps on filter technology are the result of iterating over search queries. We started with a simple query of patents from all years. Next, we refined it to include the keyword filter and a 10-year filter. There were many patents around not only particulate matter, but air particles, so we added this to the query next. As expected, the returned number of results increased, but with the 10-year filter on, we eventually visualized the network from a search list of 2,043 patents. Regarding the issues of development of the HEPA-type filters, these are the main sources used, including HEPA filter energy consumption, maintenance, and the lifespan. Also, the last item represents the source of valve performance characteristics. Here we focus on patents with the keyword fan in the patent network. The quid network shows that especially negative ion creators are related to fans. Reading through the patent abstracts revealed that the filter is simply strapped to a fan, which sucks in polluted air. This is very similar to our idea. Infrastructure technology components include various types of valves and analytical devices that measure the flow rate, temperature, and pH value. Actuated valves are divided into ball valves and diaphragm valves, both industry standard valves. Performance characteristics include quick reaction time, ease to actuate, and a straight flow in either direction. Furthermore, the technology landscape for analytical piping devices is very deep and detailed. From our research, we concluded that our application scenario does not reach the limits of its performance, so we decided to include it in the appendix. Finally, on technology, an interesting factor to consider is the clean air delivery rate, or CADR for short. This measure proves useful to compare efficiencies of air purifiers and details can be found via the link provided below.
These are the sources used in our conclusion earlier.